Good evening, friends. Today, I'm going to discuss on plastics recycling technology. Okay. So the gist of my presentation would include evolution of materials, importance of plastics materials, necessity for recycling plastics materials, and recycling technologies. So let me just start with evolution of materials. See, the era or historians have named the era as Stone Age or Bronze Age or Iron Age or Steel Age, depending on the materials that were used. Okay, and say right after 1960s, it is the polymer that has captured almost all the fields. Say at the right end of the slide, you could see the applications of plastic materials or this advanced materials. So we can very well say that we are into a polymer era or plastic era. Okay. And so these are the applications, right from commodity applications to engineering and high performance application. You can see that there are n number of plastics materials that are being used. Okay. Now, why these materials are so attractive? Why these materials have almost replaced the conventional materials is that it has unique properties. Okay, about unique properties we'll see later. Now, before going into the properties and about the recycling technologies, let me just give a brief introduction on what a plastics is and what are its unique properties. Okay, so plastics are basically polymeric materials. I think most of us will know what a polymer is. Polymers are macromolecules which are made up of number of smaller units, which we call it as monomers. Okay, so plastics is a type of polymer. And this plastics word is derived from the Latin word plasticus, which means that it can be molded. So this is a material which can be molded into any shape, okay, any intricate shape by applying heat and pressure, or just heat alone and pressure, or both heat and pressure together. Okay. And coming to the unique properties of plastics, it is light in weight. It is that much preferred in many of the applications because of this particular property, that it is light in weight. It has got high strength to weight ratio, and it has got a wide of design freedom. It can be easily processed. Just by applying heat and pressure, you can process it into any shape or size. And the energy required for manufacturing is also less when compared to the conventional materials. And this material doesn't require much of post-finishing operations. And other important properties that attract are, it is resistant to corrosion. As you have metals which are prone to corrosion, this material doesn't corrode at all. And other than that, you can also see that it has got an aesthetic look. It can be colored to a wide range. Okay, so these are the unique features or unique properties of the plastic material, which has attracted many of the fields. Okay, now because of such n number of applications, right? Because of these properties, I said that it is being used in n number of applications. So when it is very much widely used, naturally we can expect it to be, I mean, once you use it, the material will be thrown out as a waste. Okay, so that is the reason why plastics has entered into the waste stream. More of plastics has entered into the waste stream. Now, coming to the composition of municipal solid waste, right? Coming to the composition of municipal solid waste, we can see that the percentage of plastics in MSW is just 12%. Okay, rest of it, if you see, it is food and the vegetable waste, which accounts for about 44%. Paper and cardboard accounts for 17%. Glass accounts for 5%, metal 4%, rubber and leather 2%, and wood 2%. If you look at the properties of all the other materials, most of these materials, say if you take metal or glass, that can be recycled and reused. But when you take all other materials, all those materials are biodegradable. Okay? All those materials are biodegradable. Whereas if if you take into account plastic, it is very difficult to it doesn't degrade. It is very difficult to break down the chemical bonds in plastic. Okay. Now coming to the fields of application of plastic material and polymer types that are widely used in packaging. Okay, so if you just take into account the 12% of plastics, out of the 12%, 40% is widely used in packaging applications. 3% of it is contributed in agricultural sector, 9% in automotive sector, electrical and electronics accounts for 6% of plastics, and building and construction accounts for 19%, and rest others put together around 22%. Okay, so we concentrate whenever we talk about this plastic pollution, we concentrate mainly on the packaging part. Okay, the plastics that are contributed in this packaging sector includes low density polyethylene, polypropylene, high density polyethylene, polyethylene terephthalate, polystyrene, polyvinyl chloride, and other plastics like polymethyl methacrylate. Okay, so this packaging alone accounts for 40% of the plastic usage, and this is the area where we are much concerned about. So what is the necessity for recycling? Okay. Now, if we look at the statistics, India's plastic consumption is less than half the global average. So the global average is around 28 kilogram. Per capita consumption is 28 kilogram average. If you take US alone, the per capita consumption of plastic is 109 kilogram. Per capita consumption is 109 kilogram. Whereas if you take Brazil, it is 32. Europe, it is around 65. China, it is 38. India is just 11%. Okay, but what we see is the environment is very much affected because of this 11% of plastics that are being consumed. And coming to this side, that is packaging in the largest application of plastics. This, I think I have listed out that packaging alone accounts for, if you compare world usage and Indian usage of plastics, in India, packaging application takes about 43% of plastics, and other infrastructural application accounts for 21%, automotive application for 16%, agricultural for 2%, and rest of it around 18%. But when you take the case of world scenario, packaging accounts for 35%, infrastructural application accounts for 25%, automotive 17%, agriculture 8%, and others put together 15%. Okay, and there is a steady race with improvement in the life standard of India. There is a steady rise in the plastic consumption. Say initially it was about way back in 1996, the plastic consumption was around 61,000 tons. Now we use around 178 lakh tons of plastics per annum. Okay? And the top 5 plastic producing states are, say, it is Maharashtra, Gujarat, Tamil Nadu, Uttar Pradesh, and Karnataka. So these are the 5 top states which produce lots of plastic waste. And India generates about 2,600 truckload of plastic waste every day. That means we require about 2,600 trucks at 10 tons per truck to transport this waste that is being generated. And when compared to the rest of the world, we recycle about 60% of plastics. And there is about 9,205 tons of plastics that is left as such without any recycling. And we have already seen that the packaging sector is the one which contributes a major share to the plastic pollution in India. And the single-use plastic bags and styrofoam containers take up to 1,000 years for it to decompose. And it has not only affected the terrestrial system, it has also entered the entered the marine ecology. Say there is a huge threat due to this plastic waste in the marine ecology. There are about 8 million tons of plastic waste entering into the ocean every year. Okay? And the plastic packaging accounts for 62% of all the items that have been recovered in the coastal cleanup efforts. And in 2014, as per 2014, they say that 1 kilogram of plastic in ocean for every 5 kilogram of fish. And by 2050, it is expected that there will be more than plastic than fish in the ocean. So this is the scenario. Say both the land or say terrestrial ecosystem as well as the marine ecosystem is totally affected because of this plastics material. Actually, this plastics material is a wonderful material and a versatile material and a lightweight material with n number of plus points. But the negative, it also has got some negative effects. What is this plastic pollution? Plastic pollution is accumulation of plastic products in the environment, which is found to affect adversely the environment. Environment in the sense the ecosystem, which includes wildlife and human. The plastic is composed of polymeric material and the additives. Polymeric materials are actually inert in nature. They do not cause any harm to the environment. It is the low molecular weight additive that are added to the plastic to make it as a product is found to cause a lot of concern to the environment. And other than the plastic material, there may be some residual amount of monomeric material entrapped in the polymer matrix, which is also responsible for the leachates from the plastic material. And the great concern caused by the plastic material is the one that is from commodity applications. And the plastic, as I said earlier, plastics are inert in nature. Okay, they are inert. They have got a very high molecular weight, ranging from a few thousands to few lakhs. And it is because of this high molecular weight and molecular size, it takes a very long time for it to undergo degradation. Okay? And chemical degradation as well as biodegradation takes a very long time in the soil. If they are persistent or if they are just dumped in the soil, they remain persistent in the soil environment for a very long period because there are no microbes present as of now in the soil environment, which could break down the molecules into smaller fragments. That is why it is persistent in the soil for a long period. Okay? And as such, if we take the positive aspect of this molecular size, it is because of this molecular size, the material is having high durability. Okay, as an application point of view, this high molecular weight is a plus point. Because of this high molecular weight, the material has got very high durability. But then we take into account the environment. Okay, this plus point is considered as a minus point because it takes a very long time for it to degrade in the soil environment. And the adverse effects caused by the plastic materials are the benzene or vinyl chloride monomer or bisphenol A, which are present as residual material in the plastic, are found to cause cancer because most of these components are carcinogenic in nature. Benzene, toluene, all these are considered as carcinogens. They are found to cause birth defects. They also affect the nervous system and the immune system, and they are found to affect the endocrine system. Okay? They are found to affect, especially bisphenol A. That is why they say the feeding bottles that are made out of polycarbonate should not be given because polycarbonate, one of the raw material that is required for its manufacture is bisphenol A. Okay, always there is some residual amount of bisphenol A left in the polymer, which could diffuse out of the polymer matrix and enter into the milk. That is why bisphenol A based polycarbonate bottles as a feeding bottle is banned in European countries. But still, I think we are using it. Okay. Now, as I said earlier, The degradation of plastic material takes millions of years. So this is a comparative chart telling you about the time that is required for various materials to degrade. Organic waste such as vegetable and fruit peel, leftover food stuff, this takes 1 to 2 weeks for it to undergo degradation. Paper takes about 1 to 3 weeks. Paper is again a polymeric material. It's a biopolymer, right? Which is nothing but cellulose, but it could degrade within a period of about 1 to 3 weeks. Cotton cloth takes about this is again a natural polymer. Cotton cloth is again a natural polymer, which is basically cellulose. It takes about 8 to 20 weeks for it to degrade. And wood, it is again a cellulosic material, which is again a biopolymer, takes about 10 to 15 years to degrade. And woolen items, woolen item, it's again a natural polymer, which is protein, right? Protein, it takes about 1 year to degrade. And tin, aluminium, and other metals take about 100 to 500 years. But there is not much issue with such metallic components because these can be very well collected and can be recycled back. But when you take into account the plastics, it takes about millions of years for it to undergo degradation. So why should we recycle? The recycling is required or essential to save the environment, to save the valuable landfill, and to save the non-renewable energy resource, because most of our polymeric materials are manufactured from the petroleum fraction. Okay, so the petroleum fraction, which is a non-renewable resource, can be saved only when we start recycling these materials, and also to get back the energy. So these are the major reasons why we should go for recycling the plastics. Okay. Now coming to the types of plastic waste, there are basically three types of plastics: machine waste, then industrial waste, and consumer waste. Machine waste can be very well recycled in the processing unit itself. So machine waste includes the runner, flash, defective articles, purging, sweeping. All these will produce some amount of waste. These waste can be recycled within the processing unit. So it forms a closed loop. And this machine waste will not enter into the waste stream. This machine waste will not enter into the waste stream. Then we have the industrial waste like barrels, crates, films, jerry cans, roto-molded tanks, cement bags, tarpaulins, etc., etc. These very occasionally enter into the waste stream. Because of their durability, they can be reused number of times. And when coming to the consumer waste, say you have milk pouches, carry bags, cups, buckets, pens, mats, luggage, TV cabinet, footwear, all these are just dumped into the waste after usage. Okay, so many of these materials are single time use plastics, or single time used plastics, or in other words you can say commodity plastics. Commodity plastics are the one which are much found in the waste stream, municipal waste stream. Now to manage the plastic waste, the Society of Plastic Industry has introduced the identification coding system. Okay? To manage the plastic waste, Society of Plastic Industry has introduced the identification coding system for each type of resin, and this was introduced in the year 1988. And all the products which are made out of a particular material will be given a particular number. Say, for example, number 1 within the recycle symbol, the 3 arrows that represent recycle symbol. Okay, so the number which is given within this recycle symbol represents a particular plastic. Number 1 is given to polyethylene terephthalate. Number 2 is given to high density polyethylene. Number 3 for polyvinyl chloride. Number 4 is for low density polyethylene. Number 5 for polypropylene. 6 for polystyrene, and 7 for others. This others include acrylics, polycarbonates, etc. Okay. Now, how do we manage these plastics? we can, initially it was like 3 R's that was very widely used. But as far as plastics are concerned, it is the 4R technique which is very widely preferred. The most favored options are reduce, reuse, and recycle. Okay, and to some extent, as far as plastics are concerned, we can go for recovery. But least preferred one is landfill. Reduce in the sense we have to lower or we have to reduce the usage of plastics so that the waste generated is also very minimum. And if at all we are using plastics, we have to keep on using it again and again. Say, for example, when we buy any, say, soft drink, okay, say, for example, Fanta or Pepsi, what we do is we just don't throw the bottle out. Okay, we keep reusing it for other applications, right? So this also can be a good way of avoiding reducing the plastic waste into the municipal solid stream. And when reduce and reuse is not possible, only to some extent we can go for reduce or reuse. Then the next option that we can think of is recycle. So you recycle by various recycling technologies so that the material can be converted to products of cascading applications. Say, for example, if it is being used for a particular application, after recycling, we cannot use it for the same application because once we recycle it, there is drop in properties. Once when we do this recycling process, because of the second time reprocess, there is a drop in the properties, mechanical, especially mechanical properties. So because of this drop in properties, it cannot be used for a similar application. So we'll have to go for applications which are of somewhat lesser properties. That's what we call it as cascading applications. Okay. So once this recycling is also ruled out, then we can go for recovery process. That is, the plastic waste as such can be dumped into an incinerator, and it can be incinerated. And the incinerate, when you do incineration process, incineration is nothing but burning the plastic in the presence of oxygen. So when you do this incineration process, it's an exothermic process, so large amount of heat will be produced, and this heat can be used for energy recovery. So when all these are not possible, the least favored option is only landfill. That is, landfill should not be an open dump. It should be done under safe guidelines, or we have to follow certain guidelines when we do this landfilling process. Now, moving on to the recycling technologies. Okay, so when reduce, reuse all fails, we have to go for recycling. There are basically four technologies widely used for recycling of polymers. One is primary recycling, secondary recycling, tertiary, and quaternary recycling. So the technologies of recycling are put under four categories: primary, secondary, tertiary, and quaternary recycling. What is this primary or secondary recycling? Primary or secondary recycling, we also call it as mechanical recycling. Okay, and primary recycling alone can be called as closed loop recycling. Right? So mechanical recycling is a process where the plastic is subjected to a mechanical shear and is converted to polymer granules, and the polymer granules are converted back to products. Why is it called, why this primary recycling is alone called closed loop recycling? The reason is that primary recycling, the waste is actually generated from the processing units. For primary recycling, the waste is generated from the plastic processing units. Say, for example, if you're processing plastic pipes, there may be a small amount of wastage produced during the processing time. So that waste is not dumped into the, say, landfill or something like that. It is again reprocessed in the same processing machinery. It is shredded, reprocessed into the same process in the same processing machinery, and is converted to the same product. because there are no contaminants adhering to the waste that is generated in the processing unit. That is why this process is called closed loop recycling. Since there are no contaminants associated with the waste that is produced from the processing machineries, the waste is as such recycled back in the same processing unit to produce a similar product or same product. Okay, that is why we call it as closed loop recycling. The secondary recycling is a process where the material is subjected to mechanical processing. That is, it is subjected to either extrusion process or injection molding or blow molding, and is converted to a product of inferior properties. That is why we call it as cascading application. Secondary recycling produces products of cascading properties. So mechanical steps involved in mechanical recycling are grinding, washing, separating, drying, regranulating, and compounding. Okay, and I'll just show you. Yes. So the sources for the waste are industrial source, commercial waste, agricultural waste, and municipal waste. Okay. So this industry waste can be reprocessed to form a closed loop. So these waste are all collected and they are cleaned. Okay, they are cleaned and then they are subjected to sorting operation. So we may collect different plastic products. We may collect bottles, we may collect some container, we may collect plastic covers, plastic bags, so many materials we may collect. All these plastics are not of similar type. All these plastics are not of similar type. One may be made of polyester, another may be made of polyethylene, another one may be of polypropylene. Okay, so it is not possible for us to combine all these plastics together and reprocess it in the mechanical machinery. So what we have to do is we have to sort it out into different fractions. So there are different sorting techniques, sorting out. So one is density-based separation, where based on the density of the different plastic, you can bring about separation into various fractions. So you can get it as polypropylene, you can get it as polyethylene, PVC, PET. All these can be separated out by simple float sink process. Density-based separation, which includes either float sink process or you can go for air classification, wherein all the lighter materials will be just blown away. Right. Other than these, you also have separation or sorting based on difference in melting point. Each of these plastic material will have a different melting point. Okay, so it should be conveyed through a conveyor belt, and you'll have to maintain. You can have different number of conveyor belts, and when the waste stream passes through each of the conveyor belt, and you can maintain different temperatures at these conveyor belt, and depending on the melting point, some of the material will stick onto the belt and the other will be just thrown away. So this is one way of sorting out the plastics based on the difference in melting point, melting or softening point. Another classification is based on the difference in dissolution. So you can make use of different solvents and try to extract each plastic from the mixture. So there are different ways by which sorting can be done. And apart from this, you can also go for sophisticated spectroscopic techniques for sorting. So you have IR spectroscopy, right? And you have X-ray fluorescence. So all these can be used for sorting procedure. And also you can separate plastics based on optical properties. Like this, there are a number of sorting procedures. Recycling as far as plastics is concerned is easier, but sorting is very, very difficult. Okay? Sorting of plastics into various fractions is more difficult when compared to recycling. So once the sorting process is complete, then we have to subject it to size reduction. Size reduction can be done by making use of shredders and grinders, wherein the big products are converted to smaller particles. okay, smaller particles, and these particles should be subjected to cleaning process, because all these materials will have some adhering contaminants. All those adhering contaminants should be completely removed by washing process. So once you wash it, you have to dry it, and after drying, it can be subjected to extrusion. So you have an extrusion process. So this is a typical extruder system that you have. The sorted and cut and ground plastic pellets are put inside an extruder, and it is homogenized. Okay, so you heat it to different temperatures depending on the material that you process. You'll have to process the material at different temperatures, processing temperatures. So you have different zones in the extruder. You have, say, you have feed zone, compression zone, and metering zone. So in each zone, you'll have to maintain a different temperature. And once homogenization is complete, the melt will be allowed to pass through a screen filter. Melt will be allowed to pass through the screen filter, wherein any unmelted components will be filtered off, and then it will be allowed to pass through the die, and from the die it will be sent to a cooling system, so that the hot melt gets cooled into strands, and these strands will be pelletized. The pellets will be then stored in silos and will be transported. Okay? And these pellets can be converted to products. So extrusion is very, very essential process. Once the material is extruded out as strands and pelletized, the pellets can be used for further processing into products. If you want to make pipes, tubes, you'll have to go for extrusion process. And if you want to make any other molded products like chairs or bucket or something like that, you can go for injection molding process. And if you want to make bottles, then you'll have to go for blow molding process. And if you want to make films or sheets or bags, carry bags, then you'll have to go for blown film extrusion process. Okay, so this is how the reprocessing is done as far as mechanical recycling is concerned. So this is how it is being practiced in India. So the steps involved in primary or secondary recycling includes, especially it is the secondary recycling includes, it is the first step where the collection is done from house to house. Okay, so the municipal people, they come and collect the waste from the homes. So as a good citizen, what we have to do here is that we have to do the segregation right at home itself. Then the entire process becomes easier. You do the segregation right at home, the entire reprocessing becomes easier. Okay, you have to separate the biodegradable and non-biodegradable waste. So you have a separate bin at home, one for collecting all your plastic, that is your non-biodegradable waste, and another completely for collecting your degradable waste. All these degradable waste can be handled at home itself. I think in the morning session, one of the speaker was telling about composting done at home. Okay, you can very well do this process where you can degrade, or say you can compost all your degradable waste into a useful material, that is a manure. Okay, and all your non-biodegradable material can be given to a municipal worker. Okay, and the collection can be done at central point also. All these people who collect from the house, they take to a common point where it is being transported to the vans, or say trucks. From there, and apart from this organized way of collecting the material, there are also unorganized way of collecting the waste. Pickers we might have seen in our streets, picking off certain type of plastics. Okay, so this is manual sorting, we say. They don't pick all the plastics. They pick only certain type of plastics which they know about, okay, or which they feel that will fetch more money, right? So this is an unorganized way of collecting the material, and the house-to-house collection and collection at central point represents the organized way of collecting the material. Once the collection is complete, say you can see that many people are sitting here to sort out those plastics. Okay, so they are sorted out based on either the number, based on the color of the plastic, the color of the product, or based on the brand name. They do this segregation process. Now, once the segregation is complete, it is subjected to cleaning. Subjected to cleaning because there will be number of contaminants adhering to the waste. So all those are cleaned. Now, once the cleaning is complete, it is subjected to shredding. Okay, so you have shredders, mechanical shredders, which will shred these products into fine fragments. And once the shredding process is complete, it is subjected to further washing. Okay? Washing, then comes your drying process, after which it is compressed into bales. Okay? After which it is compressed into bales, and these bales are transported to the reprocessing unit. So this compression is to do size reduction so that large amount of waste can be transported in a single stroke. Then these compressed products will be fed to the hopper of the extruder. So this is your extruding machine, which extrudes out. Here you can see that through the die, it is extruded out in the form of strands. These strands will be further pelletized. These strands will be further pelletized to give pellets, and these pellets will be reprocessed in suitable machinery to convert it into a product. So this is one example which I've chosen, that is mechanical recycling of PET bottles, right? Mechanical recycling of PET bottles. So PET bottles after usage are thrown out, okay? And they are compressed to form bales, and the bales are then sorted, and the sorted bales are subjected to size reduction, right? Sorted bales are subjected to size reduction. After size reduction, it is fed to the extruder, okay, and it is extruded out in the form of fine filaments. It is extruded out in the form of fine filaments, and these filaments or fibers are taken out in bobbins, and these filaments are then subjected to weaving process, and you get as a fabric, and the fabric can be made as a shirt or whatever it is by tailoring. So this is a very simple reprocessing technique which can be adopted for any plastic material. Any plastic material in the sense, especially for thermoplastic material. So this reprocessing technique is more suitable for thermoplastics because thermoplastics can be recycled. Whereas if it is a thermoset, you cannot do this reprocessing by mechanical means. So this is about your primary recycling or secondary recycling, which we also call it as mechanical recycling. Next comes your tertiary recycling. The tertiary recycling, it is again of three types. It is chemical recycling or feedstock recycling. Tertiary recycling is of three types, two types, chemical recycling and thermal recycling. Tertiary recycling, we also call it as feedstock recycling. Tertiary recycling is also called feedstock recycling. So first let us discuss about chemical recycling. So chemical recycling is a type of tertiary recycling wherein we use certain chemicals which breaks down the polymer structure into smaller units. So the polymer is broken down into smaller units and we get back the monomeric units. So this chemical recycling, we can also call it as depolymerization process. Right? Chemical recycling can also be called as depolymerization, as producing large molecule. The reverse, we call it as depolymerization. That is, we get back the monomers, which can be used for making a new polymer. Okay? This is more advantageous when compared to, say, primary recycling, because if you take the case of mechanical recycling, we may not be able to produce a similar product when we reprocess the material. But when we take this tertiary recycling or chemical recycling, since we get back the monomer can be polymerized to give a polymer which can be used for producing the same products. Okay, and but there are many disadvantages as far as chemical recycling is concerned, because it is more expensive and a lot of chemicals are introduced in the say water body or land resource when you do this chemical recycling process. So PET, if you take the case of polyethylene terephthalate or nylon 6 or nylon 6,6, chemical recycling is more suitable. And you can also do chemical recycling of polyurethanes, polyacetals. These are the polymers, especially the polymers that are produced by condensation polymerization, can be recycled by chemical recycling procedure. So if you take the case of polyethylene terephthalate, PET can be subjected to chemical recycling. There are 4 ways by which this chemical recycling can be brought about with PET. One is glycolysis, another is hydrolysis, methanolysis, and other processes like aminolysis or ammonolysis. So glycolysis is a process where polyethylene terephthalate is treated with ethylene glycol. Polyethylene terephthalate is treated with ethylene glycol, and this glycolysis process leads to cleavage of long polymer chain into smaller fractions, and one such fraction that we get is this hydroxyethylene terephthalate. Okay, this hydroxyethylene terephthalate, plus we get some oligomeric units. Oligomers are nothing but low molecular weight PET or low molecular weight polymer. We call it as oligomers. So apart from the raw material, right? Apart from the raw material, we may also get some amount of oligomers. Then when we subject this polyethylene terephthalate to hydrolysis, when we subject polyethylene terephthalate to hydrolysis, this hydrolysis is nothing but cleaving the polymer in the presence of moisture, right? Cleaving the polymer in the presence of moisture. And this hydrolysis can be done under acidic condition, basic condition, or neutral condition. Whatever be the condition that you maintain, this polymer is being cleaved into smaller fragments. That is, you get back your starting material. So for PET, the starting material is terephthalic acid and ethylene glycol. Right? So you get terephthalic acid plus ethylene glycol when you do this hydrolysis process. And PET can also be subjected to methanolysis. That is, polyethylene terephthalate is treated with methyl alcohol, where it undergoes cleavage, polymer undergoes cleavage, producing dimethyl terephthalate and ethylene glycol. So PET is usually prepared by either a TPA process or DMT process, right? Or it is converted to this hydroxyethylene terephthalate, which is then converted to the polymer. So all these 3 raw materials that are used for the PET production is obtained when you do either glycolysis, hydrolysis, or methanolysis. You can also subject PET to aminolysis, wherein you treat it with amine. Okay? So the PET is treated with a suitable amine or ammonia, where the degradation takes place to give amides. Okay? So these are all possible chemical recycling procedures for polyethylene terephthalate. So again, moving on to the recycling of polyethylene terephthalate, we see that the PET recycling is made easier, or there are some ingredients present in the PET bottle which is found to catalyze this chain scission reactions. Okay, so if you take this PET bottle, the lid of the PET bottle is usually made of ethylene vinyl acetate copolymer. The lid is usually, the entire PET bottle is not composed of one polymer alone. You have the bottle being made out of whereas the closures, the lids are made out of ethylene vinyl acetate copolymer. And the label part, if you see, the label has got an adhesive. The label has got an adhesive, which is usually a natural adhesive or natural adhesive, which is composed of abatic acid. And sometimes labels are also made of PVC, right? And this PVC produces hydrochloric acid when you heat the polymer. When you heat the polymer, the PVC that is present as a label material will evolve HCl gas. And there is also possibility for the residual amount of PVC to enter into the PET recycling unit through the vinyl bottles. So usually the bottles are made out of either polyethylene terephthalate or PVC, right? So there is every possibility for the entry of PVC bottles also into the waste stream of PET bottle, because separation of PET and PVC is not that easy because of their very close densities. Okay, so there is every possibility for the PVC bottle to enter into the PET bottle stream. So the lid, if we do not completely remove away the lid, small amount of lid that is entering into the PET bottle stream will evolve acetic acid, because it's a copolymer of ethylene vinyl acetate. So it is found to liberate acetic acid, and the adhesive also gives out abatic acid. PVC, which contains chlorine, is found to undergo degradation at the processing temperature, or say at the recycling temperature of PET bottle, producing HCl gas. So all these acids that are produced from the other components that are associated with the PET bottle are found to catalyze the degradation of PET bottle. So the degradation of PET bottle is catalyzed by the acids that are produced with the associated materials that are present along with the PET bottle. Okay? So these will liberate acid, and these acids are found to catalyze the hydrolytic degradation of PET. And they favor the, the acids favor the hydrolytic degradation, and the metal catalysts that may be present in the polymer also are found to catalyze the thermal degradation. So chemical degradation is catalyzed by the acids that are produced, and the thermal degradation is catalyzed by the metals, residual metal catalysts that are present in the polymer. Okay, so these will favor the degradation and produce the raw material back. Okay. So I said that tertiary recycling is of two types. One is chemical recycling, and the other one is thermal recycling. So this is a type, thermal recycling is a type of tertiary recycling or feedstock recycling, where you heat the polymer. Okay, heat the polymer and convert it to a high value refinery product. Okay, you heat the polymer so that you get a valuable refinery product, which is found to substitute the conventional, say, refinery products. So this thermal recycling or thermolysis can be further classified into pyrolysis, hydrogenation, and gasification. Okay. Pyrolysis, hydrogenation, and gasification. So each of these thermal recycling procedures produce different products which are of higher value. So tertiary recycling or feedstock recycling can accommodate feedstocks, can accommodate plastic waste like plastic bottles, medical waste, tires, sewage sludge, and paper. Okay. So all these can be subjected to feedstock recycling. So you need not do, segregation. much of segregation is not required, or much of sorting process is not required as far as tertiary recycling is concerned. Okay, so you can just put it in a thermal degradation unit, subject it to thermal degradation, and as a result of which it produces, if you subject plastic bottles into thermal recycling procedure, then 70% of oil is produced, 16% of gases, and just 6% of solids are produced. And if you consider medical waste predominates especially plastics materials. Right? Medical waste contains more amount of plastic waste. So when you subject it to a tertiary recycling, there is about 66% of oil that is generated. 60, yes, and 10% of gases are produced, and solids account for 5%. When you subject this tire is again a polymer. Okay, tires are made out of polymeric materials, which we call it as rubbers. Okay, same polymeric material only, but we call it by rubber because they are flexible in nature. So the oils that are produced account for 44%, and gases account for 10%, and solids account for 42% because of other filler component, other additives present in tires. Then you have sewage sludge, which on thermal degradation gives you 26% of oil, 9% gases, and 8% of solids. And if you burn, or say if you subject paper to depolymerization, about 8% of oil is produced, 48% of gases, and 24% of solids are produced. So by this thermolysis process, it is possible to produce about 97% of monomer back. This thermolysis is applicable mainly for thermoplastic materials. Okay, and thermoplastics materials which have got a sealing temperature in the range of 300 to 600 degrees Celsius. Thermolysis is more suitable for plastics materials which have got a sealing temperature of 300 to 600 degrees Celsius, can very well be reprocessed by tertiary recycling. So sealing temperature represents the temperature beyond which there is a depropagation reaction taking place. The propagation reaction leads to a polymer. Okay, depropagation reaction leads to a monomer. So when you heat the polymer to 300 degrees centigrade, if it is found to undergo depropagation reaction, then the temperature we call it as sealing temperature. Okay, there is an equilibrium between the forward and backward reaction. The temperature at which there is an equilibrium existing between the forward and backward reaction, we call it as the sealing temperature. So the polymers which have got a sealing temperature range between 300 to 600 degrees Celsius can very well be reprocessed by thermal recycling. Polymers like polymethyl methacrylate, polystyrene, all these have got a sealing temperature of around say 350, 400, which can very well be reprocessed into the monomer by thermolysis. So this is the process flow diagram for the production of liquid refuse derived fuel from plastic waste. So segregated municipal solid waste from the municipal corporation is subjected to sorting, where plastics are separated out, and dry fraction of the RDF, and you have wet fraction. Then this recyclables like plastic films, polypropylene, LDP, PP are further segregated and subjected to size reduction. Then they are beaten for removing the dust. Then it's subjected to step cleaning, then storage, feeder, and subjected to depolymerization. Depolymerization to get back the monomer. So there are actually three types of thermolysis: pyrolysis, gasification, and hydrogenation. Pyrolysis, gasification, and hydrogenation. So first, let us discuss about pyrolysis. Pyrolysis is nothing but destructive distillation. Pyrolysis is destructive distillation, where the plastic waste is heated to a high temperature of 350 to 600 degrees Celsius in the absence or with limited supply of oxygen. So the the plastic material is heated to a temperature range of 300 to 600 degrees Celsius with very limited supply of oxygen or in the absence of oxygen. As a result of pyrolysis, three fractions are produced. One is pyrolytic gas, another is pyrolytic oil, and pyrolytic residue. And the pyrolytic gases generally have got a carbon range of C1 to C4. C1 to C4 hydrocarbon, we call it as pyrolytic gas. C1 to C4, we call it as pyrolytic gas. And these pyrolytic gases form a substitute for our LPG. And the pyrolytic oil can be further fractionated into various fractions by subjecting it to distillation process. On distillation of the pyrolytic oil, we can get number of fractions depending on the hydrocarbons present. So we get gasoline fraction, which is between C5 to C10, kerosene fraction C12 to C22, and C22 to C26 diesel fraction. So like this, it is possible to get valuable petroleum product on pyrolyzing the polymer waste. And the residue fraction that the residue that we get, we call it as pyrolytic residue, or the carbon char, which can be used in industries. Okay? The char is used as a filler for rubber. So this is about the pyrolysis. So the pyrolytic, so here if you see on distillation, on subjecting the pyrolytic oil to fractional distillation, you get gasoline, kerosene, and diesel fraction. And this is another way of representing the pyrolysis process. Here what they do is the plastic waste from the household is subjected to a pre-treatment. Instead of directly feeding it to a pyrolyzing unit, it can be fed to an extruder, because if you're not doing a sorting process, if you're not doing sorting or segregation process, your waste may contain polyvinyl chloride. Okay, polyvinyl chloride is actually very difficult to handle because of the possible HCl evolution. Okay? HCl is toxic. So it should be actually pre-treated so that HCl is removed while processing it into an extruder. So when you process it in an extruder, the HCl that is liberated is vented off, and then the remaining plastic is then subjected to a pyrolysis reactor where it is pyrolyzed. Okay, where it is pyrolyzed, and the pyrolyzed products are then subjected to fractional distillation to get the oil, and the HCl that is produced in the dehydrochlorination unit of the extruder is vented separately and is absorbed in calcium oxide. It is neutralized and absorbed in calcium oxide. Or you can directly recover it. The exhaust gas can be recovered and can be converted to hydrochloric acid. The next process that comes under thermolysis is hydrogenation. So hydrogenation is a process where the plastic is heated at a high temperature of 400 to 600 degrees Celsius in the presence of hydrogen gas. So high value products can be obtained by hydrogenation process, and this hydrogenation process is a process where we can handle heteroatoms. I said that if PVC is present in the waste stream, we must be very careful because there will be evolution of HCl gas. But if you subject this material, if you subject the polymers containing heteroatoms into the hydrogenation process, then naturally the hetero atoms are converted to hydrogenated compounds. Say if PVC is present, the chlorine gets converted to HCl and it can be scrubbed off separately. And if it is present in the waste stream, it contains oxygen. This oxygen can be removed as say water. And if it is polyamide, there is presence of nitrogen which can be converted to ammonia. And if it is rubber, it contains sulfur atom, which is a hetero atom, which can be very well converted to H2S. So the troubles related to hetero atoms can be minimized when you subject the plastic waste into, when you subject the plastic waste to hydrogenation process. And another advantage is that no super toxic products are produced in this process. So when you when you heat generally a polymer to high temperature, there is possibility for the production of toxic substances. Okay, so these toxic substances are not produced when you do this hydrogenation process. Next comes your gasification. Gasification is a process where the plastic wastes are heated to a very high temperature of around 1300 degrees Celsius under controlled atmosphere of oxygen. So gasification is heating the plastic to a high temperature of 1300 degrees Celsius in the presence of oxygen. So the basic reactions that take place is, say your polymer is basically a hydrocarbon polymer. It is found to react with oxygen, giving you carbon monoxide and hydrogen. So the combination of carbon monoxide and hydrogen, we call it as syngas, which can be used as a fuel. So this syngas can be produced when we subject the plastic waste to gasification process at a higher temperature of 1300 degrees Celsius in the presence of oxygen, controlled amount of oxygen. So the gaseous mixture of carbon monoxide and hydrogen are the primary products, which we call it as syngas. And the syngas is actually, though it's used as a fuel, it can also be considered as a valuable chemical intermediate for the production of various fuel mixture, various mixtures, say petrochemicals. So this carbon monoxide and hydrogen forms a valuable source for producing various chemicals. And the inorganic ash that is produced as a result of gasification process can be combined with concrete mortar to produce a mixture of high acid resistance. So whatever inorganic residue, the rest of all the other processes, if you see, handling of ash was difficult. But as far as gasification is concerned, the ash can be mixed very well with concrete mortar, and it can be converted to a high acid resistant product. So this is a flowchart showing you gasification process. The plastic from the households is subjected to shredding and refuse derived molder. Then it is passed on to the gasification unit. And from here, the low, so first you have the low temperature gasification furnace. Then from here, the material is being transferred to high temperature gasification furnace, where you maintain a very high temperature of 1300 degrees Celsius in the presence of oxygen. And whatever gases are produced, that is a mixture of carbon monoxide and hydrogen that is produced, is scrubbed off, and the syngas, it's actually used as a raw material for the production of hydrogen, methanol, ammonia, acetic acid, and other basic chemicals. And it is also used in fuel cells, and it's used as a fuel source. So these are all the advantages of subjecting the plastic waste to gasification. Then comes the last recycling process, technology, that is quaternary recycling. Quaternary recycling, we also call it as recycling for energy recovery. Recycling for energy recovery. So when we generally go for quaternary recycling, when it is possible, when it is not possible for us to segregate the plastics. Okay, when the plastics are commingled and when it is contaminated with other any number of other ingredients, then we go for quaternary recycling process. And the advantage of this quaternary recycling is that we get a high calorific content of the plastic, which is used up in power generation. It is used up in power generation. So basically, the power generation or energy recovery is done using incinerators. You have there are actually different types of incineration: open incineration and incineration under controlled conditions. When you do this open incineration, it is found to cause pollution because of the possible dioxins that are produced at temperature of incineration. So generally, incineration should be done under closed environment. Incineration should be done under closed environment so that the toxic substances that are produced are handled very well. They are made to pass through chimney and they are absorbed and removed, and the gases that are free from the contaminants are only discharged to the air environment. And heat that is produced as a result of the burning process, okay, the heat that is produced as a result of the combustion process is utilized in generation of power. So the amount of the heat that can be extracted from various plastics is PVC can produce, or PVC has got a heat capacity of 18 megajoules per kilogram. That is, per kilogram of PVC can give a heat of about 18 megajoules. And polyethylene can give about 27 megajoules, polyethylene terephthalate 46 megajoules, polystyrene about 41 megajoules, ABS, acrylonitrile butadiene styrene copolymer can produce about 35 megajoules, and coal. So this can be compared with that of the conventional materials which are used for giving heat. Say heavy fuel oil can produce about 41 megajoules per kilogram. Coal can give about 26 megajoules. Natural gas 36 megajoules. Milled peat can give about 10 megajoules, and paper can give about 17 megajoules. So the heat is actually comparable with that of the conventional materials that are used for heat generation. Okay. So when the plastics are totally soiled or highly contaminated, wherein the separation is not at all possible, we can go for this quaternary recycling procedure, where we can use the heat that is produced as a result of incineration for power generation purpose. And apart from the quaternary recycling, people also have tried using plastic waste for other purposes. Say it can be co-processed along with cement manufacturing unit. Okay? So this plastic waste can be co-processed because it can give a large amount of heat, which is used for heating up the kiln of cement plant. So this plastic waste along with the coal and other thing is used in the processing of cement in cement plant. Okay. So that also has been tried as far as the plastic waste are concerned. So this is a flow chart of plastic bitumen road process. Plastics can say when the plastics are highly soiled, where segregation is very difficult, we can think of plastic bitumen road. Okay, and the steps involved are plastic waste collection. To some extent, they do segregation because very high temperature plastics cannot be used. Since the processing is done at temperature between 160 to 170, this is more applicable for polymers which get softened at this temperature. So polyethylene and polypropylene can very well be used for bitumen road laying process. So plastic waste is collected, sorted, segregated, then cleaned, dried, and then it is subjected to shredding process. Now, after shredding, the stone aggregates are heated. Okay? The stone aggregates are heated to a temperature of around 160 to 170 degrees Celsius, after which the shredded plastic waste is added to it. Okay. Now, what happens is at that temperature, the polymer gets softened, and there is a uniform coating of the plastic formed over the aggregate, and this coating takes just 30 to 40 seconds. Okay, so uniform coating of the aggregates are formed over the stone, and the coated aggregate is then mixed with hot bitumen at a temperature of around 155 to 160 degrees Celsius. And the mix known as the plastic waste bitumen aggregate mix is then used for road laying purpose at a temperature of around 110 to 120 degrees Celsius. So if you look at the processing temperature, the plastic films that are just thrown out, okay, can be collected and can be washed, dried, and subjected to shredding process, and can be used for road laying purpose. And this has been already tried in many places of the country, especially Karnataka and Hyderabad. They have tried this road laying with plastic. It can accommodate, this road laying process can accommodate about 10% of plastic waste. If you go beyond 10%, then the properties of the road are lost, because plastics generally give a very smooth surface finish. Okay, so the vehicles will not have grip. The wet grip and dry grip of tire with the road will be very poor, and you use more amount of plastic in road laying. So there is a limitation that you can accommodate. It can accommodate only about 10 to 11% of plastic into the bitumen. Other applications of plastic scrap includes the interlocks. Okay, the interlocks that are made using the plastic, the sand and cement and the plastic are mixed together. Okay, that is, the plastic is melted and mixed together with this, and it is laid out, and the pavements are made with the help of plastic, cement, mortar. And the plastic waste can also be used for converting it to dustbins. Okay, the bins can be made out of recycled material. So this image gives you a picture about how each plastic is converted to product based on the recycling. PET bottles can be converted, reprocessed by mechanical recycling into barrels, and milk pouches can be converted to films, Bersati films, and plastic oven sacks can be converted to patties. And the battery cases can be converted to luggages. Battery cases made out of polypropylene. Plastic oven sacks are made out of high density polyethylene. Milk pouches are made out of, actually, milk pouches are made of multi-layered films. So you have polypropylene, titanium dioxide, again polypropylene, and low density polyethylene. So it's a combination of different layers. So this milk pouches are made into film, and the plastic oven sacks, which are made out of high density polyethylene, is converted to Nivar putty, and battery cases, which are made out of polypropylene, is converted to luggage, and the plastic carry bags can be converted, reprocessed to make it as a mat, and PVC pipes can be used or converted to make shoes. So PVC pipes, you know that it's a very rigid material, and this can be made into a flexible material. This can be made into a flexible product like shoes and chappals and other things by addition of plasticizer. So you need to compound it in such a manner that it can be converted to useful products, reprocessed and converted to useful products. So these are the references. Thank you. Yes, I think I have completed my session. And if you have any queries, I think answer.
Yes, here some questions they asked the participants. Madam, can I read out?
Yeah, yes, sir. Yes, sir.
What is the energy benefit ratio while producing fuel from plastic waste? Prakash, one of the audience side asking, madam.
Sir, can you just repeat the question?
What is the energy benefit ratio while producing from plastic waste?
Okay. So energy benefit, if you see, it is almost the same, sir. It is almost the same when you compare it with coal and other things, conventional material with that of your plastic materials.
Okay.
The advantage is that we are reusing the material. That is, we are conserving the conventional material when compared to the plastic waste. When by reprocessing or by reusing it for such application, we are conserving the non-renewable resource.
Okay, madam. Another question.
Energy-wise also, it is almost the same.
Oh, okay. Thank you, madam. Another question, madam, from Gurulingam. What are the impacts on environment if plastics burned in atmosphere?
What are the
environment effects, madam?
Environment effect? Yes. Actually, we are not supposed to burn plastics in open environments, sir, because when we burn it, we do not know which type of plastic we are burning, right? Say, for example, your plastic covers may be made of polyethylene, polypropylene, or it can be even vinyl plastic. If you're burning a vinyl plastic, there is every possibility for it to evolve HCl gas, which is considered as an, which makes your environment acidic, and it may cause so many problems, say eye irritation and other things you may have. And there is also every possibility for evolution of toxic gases like dioxins, etc. Okay, so this dioxin will stay in the atmosphere for a longer time, and we may inhale it, and these are found to be more carcinogens. These are found to be carcinogens, and so it's not actually safe to burn. This is what I was telling when I was telling about the incineration process. Though incineration is good for energy recovery, it should not be done in open.
Okay, madam. And one more question from same Gurlingam. How safe the ash residue for fertility of land when left in the soil?
Yes, actually, that's what, again, this when you do this burning process, it should not be done under open atmosphere. And when you do it openly, there is always the residual ash that is left behind in the soil. And handling of ash is a little bit difficult only because this ash somewhere or some place or the other, we'll have to dump it. Okay, so that is why what people advise nowadays is that when you reprocess as a co-process, say in cement kiln or something like that, it is mixed along with the cement. Okay, and the inorganic ash is used for construction purpose.
One more question, madam. Some Maulik.
Yes.
What about calorific value when converting MSW to useful energy?
MSW, in the sense, MSW will have more number of components, sir.
Oh, okay.
It's not particularly the plastic. MSW is a composition of many number of waste components in which the percentage of degradable waste is much higher. Degradable waste accounts for around 50%. Okay. So,
okay. So another question from Sunita, madam.
Yes.
How many times the reprocessing or recycling can be performed?
The best recycling is just 2 to 3 times only, sir. 2 to 3 times you can do recycling. You can do recycling many number of times, but the issue is that the properties will get dropped as you repeat recycling number of times. The thermal history to which the plastic is exposed is higher. Okay, first time when you process it, it's one time where the plastic is, the molecule is exposed to heat. When you do second time reprocessing, it is exposed twice to the thermal history. When you reprocess it the third time, it is exposed to thermal history for the third time. So when you repeat this thermal history many number of times, the polymer chains can break down. Okay, so you may have a combination of say high molecular weight and low molecular weight components. So when the molecular weight drops down, naturally the properties also will drop down. That is why the advisable reprocessing time is just three times, maybe 2 or 3 times only, to get better properties. But if the properties are if the properties required are inferior, then you can repeat it number of times.
One more interesting question, madam, here.
Yes, yes, sir.
Which particular biopolymer degraded faster?
That like specifically we cannot tell, sir, because the degradation rate depends on the environmental conditions. Okay, a polymer which degrades at a particular land environment within a period of about 2 months will not degrade in a different environment. Okay, because for degradation, there are 4 important parameters or 4 important factors that are required. One is the soil should have enough moisture content. It should have enough oxygen content. It should have, what is that, microbes, required amount of microbes present. Only when all these conditions required pH, okay, when all these conditions are present in right proportion, only then we can say that the material can degrade easily. Otherwise, even if it is left in the soil for years together, even your biopolymer may not undergo degradation.
And one more question from Dr. Snehal, madam. How
Yes,
about adding plastic in any material and then after heating the material? In this case, also dioxin will be emitted? Dioxin. Dioxin will be emitted?
Dioxin. Can you just repeat the question? When the plastic is?
Plastic, if we are going to be mixing with any other materials and heating,
Yes.
dioxin will be emitted or not?
Dioxin will be emitted at a temperature of around 400 to 600 degrees Celsius, sir. So what we have to do is we have to just heat it to its melting temperature. Melting temperature will be, say, well below 200 or 250 degrees Celsius. Okay. So when you heat it up to the softening temperature or melting temperature of the polymer, you will not have any issues related to such dioxin production or any chemicals, any dangerous chemicals being produced.
And one more interesting question, madam, that
Yes,
Praveen, he's
yes,
asked, what are the methods now we are doing for the waste management? That is enough, or otherwise we have to improve a lot?
Actually, whatever methods we have are sufficient enough to handle the plastic waste, sir. But the problem lies in where the lack of awareness among every individual, right? If we do the segregation right at home, right? As an individual, if you do the segregation right at home, then we'll not have any issues with handling of plastic. Say, I have given you the statistics in the initial slides that US is consuming more amount of plastic when compared to Indians. Okay, but you look at the environment there; it's neat and clean, right? They handle it so well, right? We see very often that our bins are always overflowing, or we do not throw the waste into the bins, right? Or we just mix everything and throw it out into the bin, right? So all these only actually delay the process of recycling. Actually, when compared to the rest of the world, we recycle to an extent of 60%, but that is not explicitly seen in the environment.
Any rising hands, question, sir? Jayasilan, sir?
Sir, Mr. Manivel can ask his question, sir. Yes, raise his hand.
Let them ask them, because this question has completed. Let them ask them.
Yeah. Mr. Manivel, you can ask your question. Sir, you can unmute and ask your question. Or Mr. Ravi Kumar can ask his question. Yes. Mr. Ravi Kumar, yeah, Mr. Manivel, yeah, please ask your question. Your voice is feeble. Can you be a little bit audible? We could not hear you clearly, Mr. Manivel. Mr. Ravi Kumar, yeah, you raised for a question. Yeah, one Mr. Simanchal. Yeah, Mr. Simanchal, you can ask your question.
Yes, sir. So it is a very nice representation. Madam,
Yes, sir.
actually, I have one question. According to waste management policy, what is the position of India as compared to global level? And mainly in Indian context, which waste management is commonly employed throughout the country?
Okay. So as far as India is concerned, we actually go for, say, we are not opting landfill, right? We are not opting, say, tertiary or we are not at all opting tertiary recycling. We are in the primary stage. That is, we prefer mechanical recycling rather than, as far as plastics are concerned, rather than either tertiary or quaternary recycling. Sir?
Okay, sir. Okay, madam.
Any other questions? You can please unmute and ask.
Yeah. Santosh, you can ask your question.
Hello, good evening, madam. It's a very nice presentation. What I wanted to ask you is, at the Indian context, as far as biodegradable plastics are concerned,
Yes,
where
sir.
are we actually? Have we gone into the making the product? I mean, products based upon biodegradable plastics?
Products are available already, sir. Especially carry bags made out of biodegradable plastics are available. It is available, but still we are in the preliminary stage only.
Okay, thank you, madam.
Okay.
Thank you, ma'am. Dr. Saranya can ask the question now. You can unmute and ask the question.
Good evening, ma'am. Thank you for the very informative session. So, what about the technology for biologically degrading the plastic?
Technology for
Biologically degrading the plastics.
biodegradation of plastics.
Yes, ma'am.
Yeah, it is just what we do is we just dump it in the soil and we leave it as such. This is what has been done so far. Okay, there is no proper technology. Technology in the sense you can do it along with composting. Okay, so composting can be done. Other than that, there is no well-established technology as far as biodegradable plastics are concerned, because the amount of biodegradable plastics that we are using is very, very less. Okay, so it is just the composting process that can be done with biodegradable material.
Thank you, ma'am. Dr. P.K. Chidambaram can ask his question.
Good evening, madam. You've done a wonderful presentation. It is very useful.
Okay,
and
sir.
I had one question, madam.
Yes, sir.
How the plastic waste is converted to useful one? So you are learning about how you convert it to useful one. That's my question.
Convert it into useful.
Useful.
Yeah,
Plastic
useful.
waste. What type of conversion takes place?
I actually didn't get your question. I actually, because your voice. Yeah, yes, sir. Please repeat.
Yes. So the waste, all the plastic wastes are converted to plastic oil nowadays.
Yes, sir. Yes, sir.
Yes, how they are converting the plastic oil, madam?
That is by pyrolysis. Yeah, that is by pyrolysis process, sir. Pyrolysis in the sense you will have to heat the plastic in a reactor, closed reactor, the temperature of around 300 to say 600 degrees Celsius, depending on the material that you handle, to such a high temperature in the absence of oxygen. Okay. So when you heat it in the absence of oxygen, it is found to undergo degradation, giving you a number of hydrocarbons. Hydrocarbons of different molecular weights, which can be actually fractionated into different fractions by distillation process.
Okay.
So
It is
you are able, yeah. Tell me, sir.
it is possible. It is possible to convert
It is
all
possible.
type of plastics.
Yes, yes, sir. It is possible, but a little bit costly. That's why we are not doing that much.
Okay, ma'am. Thank you. Thank you very much.
Okay.
Thanks, ma'am.
Okay.
Any other participant, if you have got question, 1 minute will be allowed for you. You can unmute yourself and ask. Yeah, if ma'am has cleared all the doubts, I think ma'am has given an excellent presentation, and no more questions from the attendee side. Ravi sir, you can take over. Sir.
Okay, sir. Thank you, madam, for being with us. It is an honor for us that you thought to be here. Now we are actually at the end of the session. Before going to the wind up the session, I can have some highlights of the madam speech. So madam has started with the plastics, and the plastic has a Latin word, and she has given the so many advantages of the plastics. And similarly, what are the waste, that is municipal solid waste and other plastic waste she has given. And similarly, most packing materials in India we are using 40%, remaining throughout the world only 30% packing we are using. So we have to be very concerned about that one. And similarly, in US we have 109 case of the plastic will be recycling, but in India only 11% is only we are going to be. So we are very lag of that one. And one more thing, if you are taking the waste, how much you are producing in 2017 to 18 years is 26,000 of the tons per day. That also we have to be think of all the Indians. And to compare the how much of plastic is going to the ocean, 8 millions of the plastics is going into the ocean, and this will be going to be affect the ocean as well as the animals as well as the fishes in the ocean. And similarly, what are the plastic pollution? About the plastic pollution, madam has given very good lectures. And similarly, how it will be going to be biodegradable? It will take the millions of years that we have to think of whenever we are throwing the plastic covers in and there. You can at least now nearly 150 to 160 participants is there. So this will be going to be as a chain link. Everybody can aware of how we are going to be use the plastic and how we have to segregate the plastic separately and how we have to be dump into the separately the plastic waste that we have to think of. And even though the health hazards, what about the cancer, birth defects, nervous and immunity system, and the blood as well as the kidney problems, everything we are going to be suffering future generation. That's why at least whether we are going to be think or not, and future generation we have to think about the recycling of the plastic. And similarly, madam has given the 7 types of the plastic how we are going to be recognized. And similarly, 4 R's has given, and everybody can aware of that. Now Rajamouli Bahubali has taken. Now Triple R one movie is coming. Similarly, madam has given 4 R's about the reduce, recycle, as well as reuse and recovery, as well as the landfill also is given. Is just like similar reflection is giving as in Vedas we studied about the Sama, Dana, Veda, and Danda. Same thing here also we have to use regarding using the plastic. And finally, madam has given the various recycling technologies, that is mechanical recycling, chemical recycling, and PET recycling, and thermal recycling, and polymerization, and gasification, and plastic recycling, and that is how we are going to be plastic will be used in the road for road laying, that is called a bitumen road process. So many applications how each and every plastic how we are going to be used as a recycling process. So it is actually very fantastic presentation, madam. Really we are understand by seeing the your posters itself. No need to explanation actually, but you have given the very good explanation. We are we are very much fond of your speech, madam. And similarly,
Yes.
Lindam, we hope all are very good evening on behalf of the organized committee and the audience. I thank the speaker once again. The day for us, she has spent it with us, and similarly, what are the info she has shared with us. This is the present time. We have to be give the thanks for madam. Thank you, madam.
Thank you, sir. Thank you so much, sir.